Hello, and welcome to this video lesson on integers, where our focus is on understanding zero pairs. Our learning goals for this video are: I can investigate the addition of an integer and its additive inverse, which is a fancy way of saying its opposite integer. And I can express zero as the sum of integers in multiple ways. Our language goals are: I can talk about integers using words like integer, positive, negative, sum, difference, opposite integer, and zero pair. Before we begin, let's review what we already know about integers. Okay, so what do we already know about integers? Well, we know an integer is a whole number, and that means that it's not a fraction or a decimal. And we know that integers can be positive or they can be negative, and integers can also be zero. So zero is an integer. Positive integers are greater than zero, and they are to the right of zero on the number line. Negative integers are less than zero. They are to the left of zero on a number line. We can represent integers with counters, yellow for positive, red for negative, number lines, and just with numbers themselves. All right, we also know opposite integers are two integers that are the same exact distance from zero, but on opposite sides. We also learned a fancy new word, magnitude. We learned that an integer's magnitude is the same as its distance from zero on a number line. So positive 5 has a magnitude of 5 because it's 5 units away from zero on the number line. And the opposite integer to positive 5, negative 5, also has a magnitude of 5. Even though it's a negative integer, the magnitude is just the number of units away from zero on the number line. So negative 5 is negative because we move left on the number line, but we're still counting the number of units, and we count 5. So it has a magnitude of 5 as well. So opposite integers have the exact same magnitude, and we also use the term absolute value to refer to that same concept. We also learned that we can model integers using a number line and counters, like this. Remember, each yellow counter represents positive 1, and each red counter represents negative 1. So in this example, we see we have 6 yellow counters. Each one of them represents positive 1. 1 times 6 is 6. So this picture with the yellow counters represents the integer positive 6, as you see here. On the number line, we see we've moved 6 units from 0 to the right of 0 in the positive direction, and we've arrived at 6. Positive 6 can be represented the same way using a number line. Okay, here's one for you to try all on your own. What integer does this picture show? Take a second to think about it. Did you say negative 4? If you did, give yourself a big old pat on the back because you got the answer right. We see here we have 4 red counters, and we remember that each red counter represents negative 1. There are 4 red counters, so that's negative 1, negative 2, negative 3, negative 4. We also see on the number line that we have moved to the left of 0. That's in the negative direction. We moved 4 units to the left of 0 on that number line, negative 4. Good job. One more time, opposite integers are two integers that are equally far apart from 0 on a number line, just in opposite directions. So we can see here that we have moved 5 units to the right in the positive direction on this number line to show positive 5. And then we can move 5 units, the exact same number of units, in the opposite direction to the left to show negative 5. So this picture shows us that 5 and negative 5 are opposite integers. We also see that the magnitude, or the distance away from 0, of both 5 and negative 5 is 5. Remember, magnitudes are always positive. And we can say that the absolute value of 5 and -5 is 5. And we show absolute value by placing the number in between those two vertical lines. So whenever you see a number represented this way in between two vertical lines, you know it's referring to that number's absolute value. Okay, here's another one for you to try on your own. What is the absolute value of the integer pictured on the number line below? Take a moment to think about it. Did you say 2? If you did, give yourself a big old pat on the back because you got it right. And if you're confused right now because that is the integer -2, remember that absolute values are always positive, just like magnitude. They're just telling us how far away from 0 is this integer. So -2 is 2 units away from 0. So its absolute value is 2 because that's how many units it is away from 0 on a number line. All right, now that we've reviewed what we already know about integers, let's dive into a new concept, zero pairs. Let's build on what we just reviewed. We'll start by thinking about the two integers, 1 and -1. These are opposite integers, meaning that they're both exactly the same distance away from 0 on the number line, just in opposite directions. We can model them on a number line like this. We can visualize the movement from -1 to 0 as a jump to the right in the positive direction, and the movement from 1 back to 0 as a jump to the left in the negative direction, like this. Now, notice how we end up at 0 when we put those two movements together. Let's try that with a different pair of opposite integers. This time we'll use 3 and -3. When we represent the two opposite integers on a number line, we see the same thing. We add them together, we meet back at 0. We can also model these integers using integer tiles or counters as well. So when we have a pair of counters that are opposites, one positive and one negative, they add up to 0, just like we see on the number line. When they came back together, they met at 0. So when we have a pair of opposites, they add up to 0. One red integer tile, one yellow integer tile add up to 0. We call that a zero pair. And when we have 0 pairs and we're using counters, we just discard the 0 pairs. We match them up and discard them. And we can also write this as an equation that looks like this. -1 plus +1 equals 0. Now, if we look at our other model, we see we have 3 0 pairs, and we can write the equation -3 plus +3 equals 0. Okay, let's build on that new knowledge to extend our thinking about this concept. We can use our new knowledge of 0 pairs to create more complex representations of integers. Let's try this challenge. What integers can we represent with 6 counters? Now, in this challenge, we have exactly 6 counters, and we have to use all 6. We can't just throw some of them away. So we have 6 counters. We have to use all 6. Remember, they're two-sided. So one side of the counter is yellow to represent +1, and one side of each counter is red to represent -1. So we can lay our counters out and flip them to change how we are representing different integers. So let's walk through this in a systematic way to see how many different integers we can represent using exactly 6 counters. So I'm going to start with +6. All 6 tiles are flipped to the yellow side, and we have 6 yellow counters, and that represents +6. If we flip one of those counters to the red side, we now have 4 yellow counters and 1 0 pair. If I discard that 0 pair, I'm left with 4 yellow counters, and that represents +4. Let's flip one more counter. Now I have 2 red counters, 4 yellow counters, but I've created 2 0 pairs. So let's discard those 0 pairs. And what number have I represented now? Did you say +2? If you did, Big old pat on the back. Yes, after I discard my zero pairs, I have 2 yellow counters left. That represents positive 2. Now I'm going to turn over one more counter to the red side. Predict which integer I'm representing here. Well, I've created 3 zero pairs. I'm going to discard my zero pairs, and that leaves me with nothing, which is 0. And 0 is an integer, so I guess I represented 0 with 3 zero pairs. 3 red counters and 3 yellow counters represent 0. So that's a helpful thing to keep in mind. Anytime that you have integer tiles or counters that you're working with and they all match up, there's an equal number of positives and an equal number of negatives, you've got 0. All right, let's keep going, turning over one integer tile or counter at a time. So if we do that, now we have 4 red counters and 2 yellow counters. We've created 2 zero pairs. We discard those. We are left with 2 red counters. Each red counter represents -1. So we've just represented the integer -2 here. Let's continue this pattern. We're going to flip one more yellow counter over to the red side. What number will we create when we flip one positive counter over to the negative side? Well, what we have now is 4 red counters and 1 zero pair. Once we discard that zero pair, we're left with 4 red counters, and that represents -4. So if you said -4, give yourself a big old pat on the back for getting the answer right. And the final step is to turn over that last yellow tile. That leaves us with 6 red tiles, which represents -6. And you can see here how I represented 7 different integers using just 6 integer tiles. And that's the power of the zero pair. Let's recap what we learned in this video lesson. We learned how to show that -1 plus +1 equals 0 on a number line. We also learned that we can show 0 by using 1 red counter and 1 yellow counter. Both of these represent 0 because the opposite integers make a zero pair and cancel each other out. So those zero pair counters, we're going to discard them and only look at what's left. We also learned that we can show any integer in a lot of different ways using zero pairs. So we can show that with counters, like in the picture down there, but also in an equation by just adding 0 to any number. Now, look closely at this bottom example here, because I'm going to give you a question in a moment where you'll take a picture similar to this and write an equation showing the number representation of the picture. So once again, 2 red tiles, that's our integer 2. 1 zero pair is our first 0, second 0 pair is our second 0. 2 plus 0 plus 0 equals 2. Okay, now it's your turn. Take a look at this picture. Look at the counters, look at the zero pairs. Remember, each zero pair represents a 0 in your equation, and write an equation that represents this picture. And one final question for you to do. Explain how this picture below represents 0.